There are 5 questions on practice question set number 19 that you did for homework last night. Of those 5 questions, 3 of those are general EMR questions. 2 of them are a little bit more specific. The general EMR questions can almost always be answered by remembering 3 key words. What are those 3 key words? We've talked about them the last couple of days. Perpendicular is one of them. The other one, good, accelerating. What's the middle one? I didn't ask for them in any particular order, but I'm listing them in a particular order. We have accelerating, then changing, right, then perpendicular. The reason I list them in that order because it helps us to remember exactly what's going on here as well. Accelerating electric charges generate changing electric and magnetic fields. Remember, we need changing electric and changing magnetic fields because otherwise they don't become self-sustaining. Changing electric generates changing magnetic generates changing electric, and so on. So accelerating charged particles generate changing electric and changing magnetic fields, which are perpendicular to each other and perpendicular to the direction of motion of the energy or the direction of motion of the wave. These 3 keywords take us a long way to answering just about any general EMR question, including 3 of them on this practice question set. Number 1 is a pretty general EMR question. We have 6 graphs here. Electric field versus time and magnetic field versus time. I want to know which of these graphs represent a situation in which EMR would be produced. What's the key word that's relevant to this? Accelerating, changing, or perpendicular? Changing, yeah. We need to look for a changing electric and or a changing magnetic field. And if we can find that, then we've identified what graph will generate EMR. Does number 1 generate EMR? Yes, because that's a changing electric field right there. Does number 2 generate EMR? No, because that's a constant electric field. Does number 3 generate EMR? Absolutely, that's a changing electric field. That's the one that we typically see, right? That sinusoidal. It doesn't matter though. If it's a changing electric field, it'll generate a changing magnetic field. And a changing magnetic will generate a changing electric. So we have EMR in those 2 situations. What about the 4th one here? That's not going to generate changing, that's not going to generate EMR because that's a constant magnetic field, right? Good. Whoops, that should be an X, not a circle. What about number 5? Does that generate an electromagnetic radiation? Is that a changing magnetic field? Yes. So that would generate a changing electric and so on. What about this one? Yes. Okay, people are nodding yes. Generates a changing, that is a changing magnetic field, which will generate a changing electric field, which will generate a changing magnetic field, and so on and so on and so on. So that's EMR. Those 4, 1, 3, 5, and 6, all involve changing electric or magnetic fields. So all 4 of those will generate EMR. Okay, so 1 for 1. Okay, 1 question so far, 1 question that is answered by remembering those 3 key words: accelerating, changing, and perpendicular. Okay, let's take a look at number 2. This is a little bit more specific now. This can't be answered by remembering just those 3 words because it's, say, one of those more specific to a specific type of EMR. It says a strong or intense source of gamma rays would most likely indicate that what? Radio waves and microwaves recombined because they're both produced by oscillating electric charge going back and forth, back and forth. Then we had infrared, visible light, and ultraviolet. We grouped them together because they were all produced by transitions of electrons in atoms. Then we had X-rays. X-rays were produced by, remember that one? Deceleration. Yeah, the rapid deceleration or the rapid slowing down of electrons. And then finally we have gamma rays. We said that they were produced by nuclear decay. I don't see that anywhere. What's the same thing as nuclear decay, or what happens in nuclear decay? Yeah, it's matter being converted to energy. So the answer is D for that one. Careful, I almost put C. I almost circled C by accident there because I saw the word matter and I saw the word energy and I saw the word converted, and I was being careless there and almost circled C. So watch that, right? Okay, clearly that's meant to trick you there. So let's make sure that we're reading the question carefully and answering what the question says. The answer is D. 3, back to a general question here, not a specific type of EMR, but general EMR. It says the relative direction of the electric and magnetic field components of EMR is what? What's the answer always going to be when we're talking about EMR? Parallel or perpendicular? Perpendicular. So it's got to be either C or D. Relative to the direction of the fields, the direction of motion is, it's always going to be perpendicular, yeah. Okay, again, one of those 3 key words, accelerating, changing, and perpendicular. Of the 3 questions so far, 2 of them were general and can be answered by remembering those 3 key words. 4, which of the following sets of EMR is arranged in order of increasing frequency? You don't know what that word photon means yet, but you can probably figure out what the question means, right? Later on in the unit, you do learn what a photon is. Don't panic about that right now. Increasing photon frequency, increasing frequency. That's the order that we memorize them in, increasing frequency. The first one we just said a minute ago was radio waves, then microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. That's frequency going up, that's energy going up, and that's wavelength going down, right? So what's the answer to this question here? From lowest frequency to highest frequency? It's going to be B. Now, this doesn't list all of the 7 types of EMR, right? It only lists 3. That's fine. So we've skipped some. But of the 3 that are listed, those are in order. How would I change the question to make A the correct answer? One word. There's 2 ways that we can change this question by modifying 1 word to make A the correct answer. What's one? Yeah, if we wanted to decrease the photon frequency, A would be the correct answer. We write these types of EMR down, and then we read the list backwards. Don't try to memorize them backwards. It's kind of like memorizing the alphabet backwards. It's hard to do. Right? It's hard to go backwards in the alphabet. It's hard to go backwards here too. We memorize them forwards, write them down, and then read them backwards, if that's the case. Right? What's the other way we could change this? Besides decreasing frequency, A could be the correct answer if we had increasing wavelength. Decreasing frequency, increasing wavelength, either of those would make A the correct answer. And number 5, back to a general one, although kind of a tough general one. Those 3 key words definitely help us in this question, but they don't lead us entirely to the answer. We've got to go a step beyond those 3 key words here. It says high energy accelerators can be used to accelerate protons to really, really fast speeds. Then we have magnetic fields produce circular paths that these protons follow. We accelerate protons to an energy of 7 TeV. That's a tera electron volt. If you don't know that number, 10 to the 12 is a tera, where are you going to find it? Yeah, it's on your data sheet, right? Now, of course, you got to convert electron volts to joules if there's a calculation involved here, which in this question there isn't. In this question, we just want to identify how this radiation known as synchrotron radiation is generated. What's the answer to this question? Yeah, the answer is C. By the protons as they move in the circular path of an accelerator. How do we know that? Like, where does that come from? What key word kind of starts leading us to that? Not completely, but starts to lead us there. No, I don't think so. I don't really see anything perpendicular helping us along there. What is it? No, remember those 3 key words, accelerate, changing, and perpendicular?
Accelerator.
The protons, as they move in a circular path, experience what?
Acceleration.
What kind of acceleration as they move in a centripetal acceleration? So as they move in a circular path, they experience centripetal acceleration. Even though that's not the way the acceleration we normally think of. When we think of acceleration, it's still an acceleration, and the EMR should be generated there as they move in a circle because they accelerate. Now, we look at an option like, say, number 4, or D, I should say, from the change in radius as the protons increase in speed. Okay, let's distinguish why an answer like D is not the answer. Increase in speed, that's acceleration, right? Okay, that kind of leads us to one of those 3 key words, right? So why is D not the answer? Let's read carefully again. It says, the radiation is created in C by the protons as they accelerate. The protons as they move in a circle. So that works, right? But let's look at D. The radiation is created from the change in radius as the protons increase in speed. So we're saying here in D, the radiation is created from the change in radius as they happen to accelerate. We're not saying that the EMR is created by the acceleration. We're saying it's created by the increase in radius. And that's not correct. Radiation is created by an acceleration, but not by a change in radius. Does that make sense? It's kind of tough there. We see the increase in speed. This one as well. We see the increase in speed, and we're kind of led to believe that that's like acceleration, so that's got to be the answer. But when we read the question a little bit more carefully, EMR is not generated by the change in mass, and it's not generated from the change in radius. So the answer for that one is definitely C. Again, one of those key words, accelerating, but we got to think a little bit beyond that as well.